Right, hello, my name is Tony van der Peet and I work for Allied Telesis out of Christchurch, New Zealand. Today I just want to start off by introducing myself briefly and then talk a little bit about our OpenFlow projects over the last couple of years and then look at some of the future directions that we intend to take vSwitch, including TTPs and this thing called OF-DPA. So you might wonder how a degree in astrophysics would lead to a career in networking. Well, already during my degree I had some part-time work running a corporate network, helping to run a corporate network. Of course in those days it was a bit easier than it is today. Astrophysics too has always been a driver of new technology. If you think about CCDs or the square kilometer array. The square kilometer array, according to Wikipedia, will have data processing needs which match that of the current internet. So perhaps it's not too unnatural that I ended up in networking. Following my degree I started working for DSIR, which was New Zealand Government Science, working in their network group, and our job was to create hardware and software to run the network and also to actually manage the countrywide network. Since that time there's really been a continuous chain of activity with the group I've been associated with. So DSIR became IRL, then we privatised and became Network Dynamics, then we sold to Secure Equal 3Net. We became part of a company in the US called Teltrend, and finally ended up in Allied Telesis, and we've been there since about 2000. Personally though, I've had some time out, and I took 4.5 years working for Telecom New Zealand, and I arrived back at Allied Telesis, my home if you like, just in time for OpenFlow. So the first mention of OpenFlow that I can remember probably is the Google announcement of using OpenFlow between their data centers. And as a new starter in the company, I was free to basically take up this new technology. And I wrote my first position paper for our company for internal distribution fairly soon after that. This was enough to get me started on a wee prototyping project with one of my colleagues called Campbell. And this was the first time we evaluated and looked at vSwitch and started using that. And it's a good choice. We've been with them ever since. We didn't make a lot of progress on this prototype. But then when I attended a internal company meeting, at which I discovered that people were far more interested in looking at a demo than seeing another PowerPoint, I got back to serious work on the prototype, basically working by myself. And very soon I realised that I needed to get flows into silicon, and I thought the best way to do this was to create my own OF-proto. But I very soon realised that one, creating an OF-proto is extremely difficult, and two, I wasn't going to be able to extend creating a single flow in silicon to creating multiple arbitrary flows with an OF-proto. So I went back to the porting guide and decided to change to the DPIF model. And at this stage we were using OVS 1.10.0. Another breakthrough came when I decided, upon looking at all the features of OpenFlow and OpenVSwitch, and all the different branches, that the best place to be was actually at the tip of master. So we migrated to the tip of master, and we've been there ever since. All our upgrades just come from the tip of master. I'd have to say there's not really a bleeding edge in OpenVSwitch. It all just pretty much works okay. From the tip of master. So I was finally able to get my demonstration going in September 2013, and this generated enough interest to get me going on a small summer project. And of course I come from New Zealand, so summer's November to February, and we basically tried to consolidate the work that I'd done. Most of what we did was to basically take OVSDB and OpenVSwitch and just make it run as intended straight on the Linux kernel, which is the basis of our products. December, that summer project was also the first time that I heard about OFDPA. And we have a good relationship with Broadcom, and they told us a bit about OFDPA, and we had a look at that. Didn't really do much at the time, and I took another look at that partway through 2014, and this was my second attempt to write a new OF-proto. And unfortunately this one ended up pretty much like the first one with not much success. 2014 was also a time when I started attending some of the Plugfests. We had a very fun and informal event in Wellington, and my first ONF Plugfest in Roseville soon after that. It was about a year ago now. 2014 was also a time in which a group in Japan started working with a controller and applications to try to round out the picture for OpenFlow or SDN for the company. So by this time, the company's obviously got a bit more interested in OpenFlow and SDN, and from February 2015, we've been able to set up a small team in San Jose. Some of them are with us today, and I've been working with this team this year. Basically, we've been aiming to get our implementation ready for release. A few features have been developed, but mainly hardening, system testing, and we're now at a position where we have released an enterprise SDN product in Japan with controller applications and our range of switches. So I promised I'd actually talk about using vSwitch. Well, I haven't really mentioned it much up to now because it basically just works. It works great out of the box. We don't really have any problems with it. Again, moving to the tip of master was a really good move for us. Everything's there. I guess from one comment I've had from the development team that they're more interested in hearing things about the tip of master than anywhere else. So I'd recommend to anyone that that's a good place to be. I have recourse frequently to the mailing lists, but invariably the bugs have been introduced by us. Very few issues to be found on vSwitch from our point of view. Some of the engineering features that provide great benefit to us include the lack of compiler warnings, very consistent code format, very good structure in the code, and very high levels of activity and support. And I'd really like to thank anyone who develops vSwitch for the efforts they've put in. They've really helped us. So just talking a little bit about some of the particular features of our products. So we implement on hardware switches, and here's a picture of a few of our models. So vSwitch is software switching mainly. We have hardware switches, so we've had to make some adjustments. Most of our switches are based on Broadcom silicon, and all of the ones we've implemented so far with vSwitch have got Broadcom silicon. There are some limitations with the Broadcom silicon. One of the more interesting ones is VLAN tagging. So while Broadcom do have an operation on some of their switches to pop a VLAN tag, most of our switches don't have that particular feature, and we've had to come up with a small workaround, which is based on something I found on the internet early in the prototyping stage, which is basically reserve a VLAN and make that the native VLAN on every OpenFlow port, vSwitch port, and then when you want to pop a VLAN tag, you just emulate that by setting the VLAN to the native VLAN, and the silicon will send the packet out without a tag. So it's a bit cumbersome, but it does work. There are some other missing matches and actions with the Broadcom silicon. We can't do much in the way of setting IP addresses or TCP UDP ports. So obviously we have to work around that, and the obvious workaround is to switch these in software, which of course causes perhaps some performance issues for us. We're using the DPIF model, and we're actually putting our DPIF flows into a particular general purpose ACL table in the silicon, and this has limited size. The problem then arises of what happens when the table is full, and at that point we have to resort to software switching. There are some mitigations, one of which is to deliberately choose not to put certain flows into silicon, especially flows which we know in advance will have a very low packet rate. So ARP and Neighbour Discovery Protocol are two candidates for that. We also see this as an opportunity to add some value by dynamically selecting which flows should be in silicon or not in silicon based on the packet rate, which is not something we've worked at yet. Even though so far it's all been Broadcom, we do have a variety of Broadcom switches, and we do need to be careful with the differences between them. And of course this will be a problem more when we start moving to some of our other hardware switch platforms, as well as implementing on some of our software routers. CPUs and hardware switches can have limited performance. All the switching is done in silicon, so we don't need a fast CPU, and this represents another challenge for us. One of the things we're going to have to address is to understand these limitations and document them for our users, and this will be an activity that's ongoing for us in the near future. The amount of code we've had to write is actually surprisingly small, at least with the DPIF model. We have our own NetDev, which is based on NetDev BSD, and we have made some additions to DPIF NetDev, mainly to do with getting flows in and out of silicon, as well as collecting stats from the hardware flows. And we have to collect stats because otherwise the CPU doesn't see the packets and it wouldn't know to keep them alive, keep the flows alive. So some of the future directions we'd like to go with this work. So talk a bit about TTPs. So here's a representation of the flow tables. And OpenVSwitch, being a software switch, will support any number of tables, and it will support every single match in action that's going. And this is all very flexible and very good, but any given application will only ever use a subset of the tables, and will have different matches and actions in each table, typically. And you might represent that something like this. So table 0 could be your ingress port and VLAN identification. Table 2 could be a route lookup. Table 6 could be egress port selection and a destination MAC address change. So what's a TTP? Well, a TTP is a table type pattern, and it's actually a formal description of this flow table structure. TTPs have been written in XML and JSON, and a number have been published by the ONF. I would refer you to the ONF website for further information, but Kurt Beckman at a recent member working day did a presentation on TTPs, and he's allowed me to use one of his slides which is quite instructive, which is this thing. So you can see here in the yellow there are some TTPs which are more aligned towards the application. And an application might directly use the TTP or come through a northbound interface based on some of these TTPs. In the red there you see different TTPs which are actually more aligned to the device, and they are more a representation of what the device is actually capable of doing. And again, app Z there, for example, can directly use the TTP, the device TTP. At the bottom you will see different devices, one of which has a couple of application-centered TTPs in it, which is one of the things I'd like to consider doing. And the other devices there will have their own device-specific TTPs in them. So TTPs, both types, this application-centered and the device-centered TTPs have been created. And I'd refer you to the ONF site again. Project Atrium has defined an application-centered TTP. Now this is actually a relatively simple document. It's only really got a couple of tables and there's not that much in it. An example of a more switch-centered TTP comes out of OF-DPA from Broadcom. And this thing is a far different beast. It's got hundreds of pages, it's very complex. Talking a little bit about OFDPA, which stands for OpenFlow Data Plane Abstraction. This diagram is from a Broadcom document, the OFDPA, I think version 1. And this really represents the silicon flow table inside a Broadcom switch, in particular the Trident 2, although it's applicable to most of their other switch chips. So you can see all the different tables that appear in the silicon. And if you think this looks a bit like an OpenFlow flow table, well, you're not wrong. If we can actually create a model in which OpenFlow flow tables follow the same structure and the same pattern, it will then be possible to map those OpenFlow flow tables directly into the hardware, or into the silicon. A TTP has been created for OFDPA. There's been an ONF working group working on this. And as I mentioned before, this is a bit more complex. It runs to hundreds of pages. It's got lots and lots of tables. It's a very complex document. However, you can see that at the cost of constraining somewhat the flows that you're allowed to put into the flow tables, you are able to achieve a Y-speed performance based on the fact that you can put those flows directly into silicon. So here's what I'd like to do to open vSwitch. I'd like to support TTPs. I think looking at the application-centric version of TTPs, this could be an optional parameter under ofproto DPIF. We could optionally configure a TTP file via the database by the OVS And what this would do, if present, it would actually affect the table features response that OpenVSwitch generates. It would also affect the rule processing in that rules would be checked against the TTP. Because TTPs have been published as JSON documents and there's already JSON support inside OpenVSwitch, it's possible that this could be a relatively simple thing to implement, although I haven't tried it yet, so I don't really know. In terms of supporting OF-DPA, which is really the holy grail for me, being a hardware switch guy, I'm looking at supporting a new OFproto yet again. I'd like to call it OFproto TTP. And in this case, the TTP would be mandatory. I'd put a sublayer in called TTP, which may implement the TTP as data and code, or it could potentially use generic code if it was created for the OFproto DPIF as described above. The sublayer would also then implement the hardware mappings for the TTP. So when a rule is added at the flow level or the flow table level, this would go straight into hardware. By keeping it in a separate layer, I'd also be able to put in Broadcom specific code and keep that apart from the rest of the code. I've also found from bitter experience that quite a lot of DPIF functionality would have to appear inside the sublayer. And that's reflected in the way that I've actually started implementing this stuff. So I have started working on it, and I will implement as much as I need to do to allow us to implement OF-DPA. However, I would like some level of support from the Open vSwitch community if possible. In order of preference, any advice going on my ideas on how to implement and on my designs would be great. Even better would be being able to support this in the upstream project. I don't really want to be carrying these patches through forever, and every time I upgrade I'd have to change my code as well, as I've found again from bitter experience. And of course, the best of all would be actually to get some help and some other interest with the implementation. However, I can understand that there might not be huge enthusiasm for this work for a couple of reasons. One is you might look at TTP as being a limitation to Open vSwitch rather than an enhancement. Open vSwitch can already do everything. Why would you want to shackle it by putting a TTP in the way? The other one is that Open vSwitch is primarily, first and foremost, a software switch, and we're being driven here by hardware considerations. So it's possible that this work is not a good fit for the Open vSwitch development in general. However, I am prepared to be pleasantly surprised by an upwelling of support for these ideas. But at the very least, I would love a chance to discuss my work with the experts. Thank you.
Thank you for that. We have plenty of time here for questions. If anybody would like to step up to the mic, I'm going to take advantage of my advantage here by asking a question myself. So one of the I have actually looked at TTPs and contemplated at one point implementing them, but the issue I ran into reading the TTP spec was that TTPs are not entirely machine interpretable. There are some bits in them where they are just English text strings, and so OVS would need some additional annotations to be able to properly enforce them. Do you have some thoughts on how that might be done?
Well, I haven't got very far with any of the implementation, and I know there are lots of issues that will probably arise. One thing I have thought about doing is potentially coming up with some sort of intermediate format which you might take the TTP and interpret it and generate some other type of file that's more readable.
Okay.
But, I hadn't really thought about that too much.
I also remember talking to somebody who was involved pretty tightly with the TTPs, the definition of them, and I got the impression from him that you weren't really meant to enforce them, right. Which seemed I didn't quite understand. So maybe I misunderstood him.
So, just one thing I can say is that the work I've done so far with the OFproto TTP and trying to implement OF-DPA is that in terms of the table features, you can't really express all of the complexities of the TTP in the table features response. You really have to take a union of everything that's in there, and that becomes your table features response. So when you see a table features response, it doesn't necessarily tell you everything. It doesn't tell you all the different constraints that you might have on the matches and actions in a given flow table. So,
okay. Since we're talking about table features, I feel like we should take our question from Jean here.
During your presentation, you mentioned that you don't push all the flow in hardware. Some of them you keep them in software.
Yeah.
And I was curious, you didn't seem, when you talk about OFproto TTP, I would have expected that to be one of the important features of that OFproto, because this is a tricky issue, because if you want the wildcarding, the priority to work right, you need to have a right model. And I don't know, maybe the right model is to have separate table explicitly exposed to OpenFlow, but trying to put them on the same table is tricky.
So I'm not sure I understand the question, but what I can say is that our current implementation is very much DPIF based, and OFDPA, an implementation with OFDPA, would effectively be totally incompatible with the DPIF model. So what we expect to be able to do, now it may be possible to create some sort of hybrid switch where some of it's using the DPIF model and some of it's using an OFDPA model. But yes, you're right, once you're using OFDPA, the rules should go straight into silicon, and you should never really see packets at the CPU at all.
Oh, so when you go with OFDPA, there is no software table? No software, no
There
flow
will be a
sense.
software rule table, but those rules will be put into silicon,
Okay.
and the silicon will be doing all the switching of all the packets. or it
Okay,
should
because
be.
earlier you mentioned that you were keeping some rule in software and not pushing everything in hardware, but if you are OFDPA, you push everything in hardware.
Yeah.
Okay,
Yeah.
thanks.
So I had a question about sort of how people configure this switch. I'm assuming that configuration agents would just speak essentially OVS-DB to it. And my question for you is, I guess, what's your sort of customer response and reaction to switch to a hardware switch that you can program using OVS-DB? I think, from my perspective, it seems like it might be a very nice thing that I could program both OVS software switches and hardware switches sort of using the same API or the same protocol and mechanism, but certainly it might be a challenge for people who are used to Cisco CLI or NetConf or SNMP or whatever.
So currently we have an industry standard CLI, and that's the only view that the users get. We're using OVSDB, but we're translating our command set into OVSDB commands. So Open vSwitch is configuring itself from OVSDB, but we're controlling very much what goes into OVSDB.
Do you see any? I guess to follow up. So basically, OVSDB isn't exposed externally, at least not currently.
No, not at all. Not at the moment, anyway.
A quick follow up. There are certainly obviously really irritating limitations to this Broadcom hardware. Do you think there's any hope for better silicon that doesn't have all these kind of problems that make it unsuitable for OpenFlow?
Yeah, we don't actually have Trident 2+, so that would be probably the one that's the best fit. I think, it's fairly obvious to me that OF-DPA was created by Broadcom in order to make a better mapping between what OpenFlow can do and what their silicon can do. And to me, it's quite a powerful model because it gives you, access to a wide range of ASIC capability, but using the openness and the flexibility of OpenFlow. So that's a great model. Whether or not, we're obviously tracking, what the industry's doing, and someone's going to come out with an OpenFlow switch at some point. Whether that's going to be a relatively cheap thing to buy or not, I don't really know. So we'll do what we can in the meantime to use our current products and basically make them work as best we can with OpenFlow.
Good, thanks.
Hi, you mentioned a few times the difficulty in implementing an OFproto provider. Mm-hmm. I'm just wondering what was the problems that you encountered?
Well, so the first time I started out, I looked at the OFproto provider.h, and you create that table, and the very first thing you have to do when you want to make something work is add some ports. Now, a lot of that port functionality is down in the DPIF layer. So I found myself pulling in a whole lot of DPIF code into my OFproto, which is why this time around I've actually just taken a copy of DPIF NetDev and some DPIF NetDev and OFproto DPIF, and just kind of turn those into TTP, and I'm just going to keep working at that until I've got something that does what I want my TTP to do, and then I'll just have to rip out all the other code. But there's a lot of functionality, and I'm not sure if this is deliberate or it's just worked out that way, but it just seems to me that a lot of the functionality that's quite generic is down in that DPIF layer. I've found it hard to untangle all that and make it work. And I'm sure if I had a bigger team, and we spent a bit more, this has all been sort of almost part-time activity for me up to now, so we really need to get a bit more serious about it as well.
And just another quick question. You said that when a match in action wasn't available in hardware, you'd you'd reverse offload it to software. So what was the mechanism you used? Did you offload it, or did you send it down to the kernel space data path, or did you write your own code, or did you use the
So we're using dpif netdev, which means we're not using dpif Linux, which means we're not using the data path. So all of our software switching has to come up to Silicon and then back down. And the main reason for that is that our version of Linux does not support switch ports as separate devices. Now I know that's changing, and the Linux kernel is getting some support for multiple switch ports and based on a ASIC switch, but we're not there yet. So we're still using a netdev model. It comes up through the netdev and dpif netdev and then back down again.
Okay, thanks.
So we're unfortunately at the end of our time for this session. But
comment?
Is it a quick question, Joe?
It's a quick comment.
Okay, go ahead.
There is an effort in Open Daylight going on to basically do a schema for TTPs in Yang. And in fact, that has been reasonably successful. You can actually machine read in a TTP. We did it with the OFDPA TTP. But
Right.
there were some changes that were needed.
Okay.
So I wonder if you're referring to some of the stuff that's going on in these mapping layers? Because I think Kurt's presentation talked a little bit about Open Daylight and
I think that might have been more of a comment on how I said they weren't entirely machine readable, and I
Right.
think he's
Okay.
saying they're machine readable enough.
And they're machine readable enough. They should be more machine readable. There should be an actual schema, JSON schema
Yeah.
for them, but there isn't.
well, this is all stuff that I've yet to discover because it's very early days for us implementing this stuff. But any advice is great. Thank you.
All right, let's thank our speaker one more time.
Thank you.